All right, so climate smart dairy, how it fits into dairy systems. I'm sorry, I'm going to turn my back on you guys because I'm going to use quite a bit of pointing here. So how it fits into dairy system sustainability and how it fits in a very big picture, so global concept that I'm going to try to touch on today. So let's start with a few ideas of sustainability, sustainable development goal, and climate smart dairy. So I'm sure you've learned those concepts somewhere, somehow, that there are three pillars of sustainability: the social, environmental, and economic, sometimes referred to as the three Ps: people, planet, and profit. I don't like that image because I think it gives you an impression that they are independent of each other and they are separate things. Actually, they are all tied together. And we can only move forward in the right direction if we look at the interaction between those pillars. The interaction between economic and environmental, for me, has to do with efficiency of natural resource or any economic resource use. The interaction between economic and social has to do with equity and justice, social structure, people having a fair take, a fair shot. And the interaction between social and environmental, as far as I'm concerned, has to do with health of the systems, health of our democracy, health of our environment. And so it's only when we take into account the pillars and where they interact that we can reach some of those high-level targets and objectives that are built in the Sustainable Development Goals. And I believe that climate smart agriculture, climate smart dairy is a subset of those Sustainable Development Goals, as I'm going to try to share with you today. So here are the 17 goals. They've been put together and signed on by pretty much all the nations around the world at the United Nations about, 15 years ago, 16 years ago. They are set to expire in 2030, so we are halfway through. And obviously, the dairy industry, where does it fit? Well, we produce high-quality food, so it contributes to zero hunger. That's kind of a stereotypical image as far as I'm concerned, and we need to go well beyond that myopic view of what the dairy industry is all about. Actually, if you think about it, I've been thinking about this. It contributes to a lot of those goals. But what I want to point out here is the fact that, looking for my pointer here, that within those goals, sustainable agriculture is built in the zero hunger sustainable development goal number 2. So that's where sustainable agriculture fits in. There are specific indicators, and there is a total of 231 indicators. So there's a lot of opportunity to look for targets that helps advance human development, human society around the world. So we need to look at dairy from multiple dimensions in how it contributes to all those different goals, as far as I'm concerned. Actually, the FAO, so the Food Organization, Agricultural Organization of the United Nations, a few years ago, published this graph that highlights the contribution of the livestock sector, so not just dairy, but dairy, beef, and other animal product, to the Sustainable Development Goal. And you see that, they basically, go back. Let's the response here. Okay, so the pointer is here. So 8 of them, the livestock contribute positively to 8 of them. They are a challenge uniquely for 2 of them, issue of water related, whether it's rivers or the oceans. And then for 5 of those goals, it could be positive or negative depending on how we manage the system, basically. All right, so now climate smart agriculture, as Paul, kind of highlighted to you in the introduction, it has three pillars as well. The first one has to do with food security. The second one with adaptation to climate change. The third one, mitigation. So originally, this was an FAO, United Nations initiative, that was kind of targeted more to the developing nations, but it's supposed to be across the board, right? It's applicable to us as well. So, and as Paul said, in the face of climate change, how do we produce an agricultural system that's more productive in a sustainable way, that provide increased income to the producers, and in a way that's more resilient, and where we produce less greenhouse gases? Okay. So now, let's talk about those three pillars a little bit, and I'm going to provide you some broad perspective. Climate change. All right, so climate change, this is the total worldwide greenhouse gas production in 2019. If you don't know what gigaton is, don't worry. It's a big number, okay? It's a huge number. All right, fossil fuel contribute 70%, 74% of all the greenhouse gas emission in the form of CO2. Agriculture worldwide contribute about 12%, and livestock, so animal itself, the manure of the livestock is a good part producing methane, and agricultural soil is also contribute quite substantially to the emission of nitrous oxide, okay? And then depending on how we use the land, this is that purple bar here, we can also lose carbon dioxide from deforestation in the soil, depending how it's being managed. So this is the annual global carbon budget since pretty much the Industrial Revolution. And what I want to show you here is the 2021 numbers. We released 9.5 gigaton of carbon to the atmosphere with our combustion engine. But there is a buffer in the system. This is something I want to really get across to you today, this idea of buffering. And I'm going to elaborate a little bit on that. The land absorbed 3.1 gigaton out of that 9.5. But the land was a net producer of carbon, primarily worldwide, primarily because of still the deforestation happening in many parts of the world. The ocean also absorbed a substantial amount of that CO2 that we put into the atmosphere. And what doesn't go in the land and the ocean end up in the atmosphere. And so we have an accumulation of about 5.1 gigaton of carbon in the atmosphere in 2019, whereas we produced 9.5 fossil fuel. So the system has an ability to adapt. And what we don't want to do is go beyond the limits. And I'm going to try to elaborate a little bit on that in a moment. All right, so here is again, now this is the cumulative. So it's not per year, it's since 1850. And what you see here, as far as I'm concerned, if the question is how can agriculture contribute to decreasing the accumulation of CO2 in the atmosphere? So how do we get climate smart in agriculture? Looking at the big picture, it's using or producing renewable energy. It's about reducing the emission, and it's about trying to capture and sequester the carbon on the land. So to me, again, this fits directly or indirectly into some of the Sustainable Development Goals. All right, so climate smart agriculture clearly has to do with Sustainable Development Goal number 13, which is climate action, which, you know, I don't want to hurt anyone's feeling here, but it's nothing to do with carbon footprint of milk, okay? It has to do with reducing emission, period. Okay? And that's very important for everyone to understand. So, globally, there was another publication from the FAO and the Global Dairy Platform. I suppose some of you are aware of what the Global Dairy Platform is. On what happened to the dairy industry between 2005 and 2015. We got 11% more cows in the world, dairy cows. They produce, on average, 15% more milk per cow. That's good. So we have an increase in the world milk supply between 2005 and 2015 by 30%. We can say it's a good thing, right? We're contributing to Sustainable Development Goal number 2. We supply the world with milk. We got a reduction in the carbon footprint of the milk from 2.8 to 2.5 kilos of CO2 worldwide. That's good, right? We're reducing the carbon footprint of milk. Well, the bad news is that because we got more cows, we've actually produced 18% more total CO2 in that 10-year period. So we are not going in the right direction, as far as I'm concerned. If we really want to contribute to reducing the emission and do our share of reducing the emission worldwide. I know it's a trade-off, it's a balance, but this is the numbers. So to kind of give it a good, sugarcoating the message here, the authors of the paper said, well, the total emission, if cow productivity hadn't increased, would have been 38 instead of 18. it's kind of sugarcoating the problem, right? So, and this is true, those numbers are globally, but I know for a fact, because there was a publication recently, California, same story. If we were to do the numbers, Wisconsin, it would be the same story. Okay? So, now let's talk a little bit about adaptation. Adaptation is about resilience, and I'm going to, again, give you the big picture with what scientists refer to as planetary boundaries. Start with a little analogy, physics. You got a spring, if you put a weight down, it's going to, stand within the limits of its capacity. You take the weight off, the stress off, it's going to go back to its normal position, and you can use it again over and over and over again, right? If the same spring now is overloaded beyond its limits of its capacity, you're changing the state of that coil, and it will no longer work the same way it ever did before. It was intended to, correct? So that's what resilience is all about. That's what, in our Earth system for climate change, this is exactly what's going on. Here is another analogy that, is maybe more relevant to what I'm going to show you next about the science of climate change. And, I don't want to scare you again with, reminding you of your chemistry class in college, but, that's reality. Titration curve. So you add a certain amount of acids to a base, and you got very little change in the acidity of the system. But you keep pushing, you keep pressing, you keep adding, and the same amount at some point is going to create a big change. Oh God, what's going on, right? So we got a system, a buffering systems. As long as you're within that buffering systems, everything looks normal, but the system is under pressure. The system is struggling. And at some point, if you go over a certain level, a tipping point of some sort, the same stress, business as usual, and now it's catastrophe. Things are a different place. Okay? That's where we are with climate change. So, and this is the real science, group of very bright scientists publishing in the journal Science. So they basically look at what they call planetary boundaries, and there are 9 different areas of concern globally. Climate change is one of them. But here's the concept that they use. So they try to define globally what is the safe operating zone. The safe operating zone, the zone of uncertainty where we get an increased risk of impact. So this is our buffer zone, the yellow part. And then if we go beyond this tipping point, at some point, there would be a real high risk that life will never be the same on planet Earth for human beings. Because this is all done in the perspective of society that keeps going into the future the way we build a society on the basis of the past, okay? And so we got control variables, and those control variables, put pressure on the Earth systems. If everything is fine, we can continue to thrive as human society, but if we go past the tipping point, we are real in hot water, one way to put it. All right, so where are we in this buffering capacity here with climate change? This is my next slide. So they use the CO2 in the atmosphere, concentration of CO2 in the atmosphere as the control variable, and they are looking at 350 ppm as our planetary boundary. So going beyond that, we start to get into a zone where things are changing and we're not quite sure what's going to be next. The scientists decided that about 450 ppm in the atmosphere, that's probably where we need to, if we go beyond, we're going to be in real trouble. Well, here are the facts. In 1990, we were at 350. In 2021, we are 412. So in the last 30 years, we've moved pretty darn far to the right and getting pretty darn close to the red. Okay? So this is the 9 areas that they had on that paper, and 3 of them, we don't even know what the boundaries are. 3 of them, we are okay: stratosphere, oceanic acidification, and freshwater use. Climate change is still in the yellow, but as I just pointed out to you, this was done in 2015. So by now, we're pretty darn close to the red with climate change. And then what I want to, the reason I really had this slide up here for you is because we're all about climate change, and I agree with that, but look at the red. So where we've already passed, the tipping point, and it's about genetic diversity, worldwide, in plant and animals, and the release of phosphorus and nitrogen into the environment. Life will never be again the same because of this, and it can only get worse if we don't do something quick, okay? And agriculture, unfortunately, has to do with the loss of genetic diversity and the release of nitrogen and the phosphorus in the environment, unfortunately. So, not everybody contributes equally to the problem, but unfortunately, again, there are some hotspots in the world about the release of nitrogen and phosphorus into the environment, and you see that we are part of the issue here, as well as Europe, as well as some of the Asian countries and the Himalayas. Okay, so now about mitigation. There are many opportunities to reduce emission on the farm, and again, we need to be thoughtful about what is the objective. Are we trying to reduce the emission per kilos of milk, or are we trying to reduce the emission per unit of time, the emission period? So we can work on nutrition, genetics, rumen modification, animal health, manure management, pasture management. There are many opportunities. Some of them, they are basically the best practices. As Paul said, a lot of this is about rehashing the good practices on the farm. But there are a lot of work done, by scientists to look at 2 years, 5 years, 10 years, 20 years down the road. Okay, so more specifically, reducing emission on the farm can be done by reducing nitrous oxide for the cropping systems, and that has a lot to do with nitrogen fertilization. So we need to think very systematically, how to capitalize on legume, for example, to reduce the need for external nitrogen fertilization and thus reduce the emission of nitrous oxide, which is directly proportional to the use of nitrogen fertilizer. The herd, we're talking about reducing the enteric fermentation. This can be done directly by nutrition, breeding. We are now, at the stage of actually trying to select cows that are low emitters cows, but we can also do that with greater efficiency cows, and that's already going on. Indirectly, we can alter the reproduction and the health of the animals and reduce the carbon footprint with that. Manure, it depends how the manure is being handled, if it's a solid or a liquid, but we can handle both nitrous oxide or methane being released out of the manure. And again, we know that storage time has a big impact on emission as well as processing. I'll just talk a little bit more about that in a moment. And then what we do in the soil, can help capture carbon in the form of CO2 or release carbon in the form of CO2, depending a lot on the tillage systems and also nitrous oxide. But I don't think we need to look at those as, again, separate entities to work on. We need to look at it, each producer needs to look at their own context, their own farm, and see how they can capitalize on the idea of the balance among the parts, and in specifically the recycling within that system. A case study of Switzerland, of climate-smart agriculture. So a little bit of background. I got 3 minutes, I'll be done. All right, so dairy production in Switzerland contributes 4.3% of national emission. In the US, it's about 2.5%. The Swiss had decided to contribute, their fair share to Sustainable Development Goal 13 by having a 20% decrease in emission of the 1990 level in 2020. Well, they missed the target. I don't know what we did, but I know they did miss the target. They recognize that. So Nestle, one of the larger processors there in the world, as you know, wants to be a net zero emitter by 2050. So they had this private-public partnership, including government, processor, producer, and university. That must remind you a little bit of exactly what our chancellor was talking about a moment ago. So when they sat around the table, they recognized a few facts. Number one, the Swiss dairy farmers' income was far below the national average. I think it's pretty generalizable knowledge that dairy farmers around the world have a salary below average of the nations, right? So not quite different than where we are here. They recognize that adopting climate-smart practices in the short term can add to the financial burden on the farm. But they asked the question of what is the most appropriate and relevant practices in the Swiss context. And then they wanted to make the system fair so that, it was farm size neutral. So what they decided to do was to develop a program that give temporary financial incentives to farmers to have goal-oriented premium for their payment. The farmers could choose any one of four practices. Number one, increase the number of lactation per cow. Right? Why? Well, because as long as we have heifers in our herd, they produce methane, but they don't produce milk. Once the cows start milking, we're starting to dilute the emission of the herd. So the longer you can keep the cow in the herd, the more you're reducing the share of non-productive animal in the herd, and therefore, reduce the emission per unit of milk. This is controversial. There are people who would think we should, this is not the right way to go. I can tell you that. Second opportunity is to increase the lifetime performance of the cow. And that can be done in many different ways, but the logic is simple. If you got higher producing cow, they produce more milk per day and they eat more. But the slope of the curve of increasing milk is steeper than the slope of the curve of producing methane. So if you do the ratio of methane per unit of milk, you're decreasing the milk carbon footprint. Okay, so you're decreasing the footprint. You may not be decreasing the amount of methane, but you're decreasing the amount of methane per kilos of milk. Okay? Biodigestion were the third options, and clearly there's work that's been done here, right here in Wisconsin, that really indicate that the processing through biodigestion can not only reduce substantially the emission that takes place in the pit while the manure is sitting there, so much less emission here than here, but you can take an awful lot of credits by displacing a lot of the energy from the grid by producing it yourself. The last opportunity for those farmers in this program was to couple dairy and beef production by using dual purpose breed and sperm sexing. So the idea here is the kind of a big picture thing where the carbon footprint of meat is considerably higher than the footprint of milk. But the carbon footprint of dairy beef is considerably lower than the specialized beef. So if you increase the proportion of dairy beef in the meat supply chain, you're actually going to reduce the carbon footprint of the meat supply to the population. So this is a case where the dairy is actually helping the beef to become more environmentally friendly. And the idea is everybody, is better off at the end of the day. So my final thought is that we need to continue work on the farm component and how to make them more sustainable. But we need to put that in the context of the dairy farm sustainability, social, environmental, and economics. And this needs to be done in the context, the Wisconsin context, the national context, the Peruvian context, the China context. We need to think of the dairy sustainability of the farm as being part of the sustainability of our agricultural system. All right? We got the crop people. We got the beef people that we need to work with. We need to put the agricultural sustainability in the context of the food system sustainability. And all that, in my view, needs to be, aimed at meeting some of those targets of the Sustainable Development Goal of the United Nations. And so this will not be an easy task. We need a lot of things. We need to continue to do reduction research, but we need to do more holistic research. We need to be discipline research oriented, but we need to do a lot more transdiscipline research. We need to be very specific about what we want to achieve, but we also need to think more universal concept. We need to think about how to improve the current systems, but also how to transform the system to be more sustainable. And with that, I really appreciate your attention, and I'll be happy to answer any question when we have the discussion. Thank you.